Hi everybody, my name is Iñaki. I'm a solutions architect here at NVIDIA. I've been here for a couple of years. I focus on AI infrastructure and LLM deployment. And today we're going to be going over NIM Operator. It's one of our best orchestration tools for deploying and scaling NIMs. And we're doing it on Vultr Kubernetes Engine today. So there's a couple different ways to deploy generative AI and LLMs and NIMs. You know, there's these managed Gen AI services. You hit an endpoint that is given to you. Sometimes you go through a web UI, et cetera, et cetera. That can be inflexible sometimes, right? You want to be able to deploy your own models, or maybe use open source models, understand what's going on under the hood instead of just trusting it, right? And then using your own custom data with that can be complicated as well. So sometimes you want to roll your own deployments on your own infra. Maybe you have on-prem infra. You can't deploy closed source models on-prem. So we need a way to do that. And so we have NIMs, which operate on open source models for so many different use cases. I won't read through them, but there's a bunch. There's almost over 100 NIMs for different industry use cases, all with often with LoRa support for different use cases. So introducing the NIM operator. So it simplifies the deployment and management of NVIDIA NIMs for AI pipelines in Kubernetes. So you show up with a container and a model. Writing your own Helm chart that is scalable, has metrics, things like that is really difficult. And so NIM operator is kind of this overarching package to do that. That fits into the NIM ecosystem. So it sits on top of Kubernetes. It's essentially a Helm chart that it has a lot of tie-ins to Prometheus and metrics for auto-scaling and ingress. So yeah, another thing that it has is model pre-caching. So when NIM containers start up, they pull a model from NGC, and so you want to cache that model to then horizontally auto-scale your deployment and shrink it down as well, depending on if you need more, and you don't want to pull that model every time, right? Okay, so this is the high-level architecture for NIM operator. So we have essentially a lot of custom resource definitions in Kubernetes. We have NIM pipelines and services, which allow you to deploy very complex AI applications that involve a bunch of different NIMs. So we have embeddings, we have vector databases, things like that allow you to, and this simplifies that by having a single pipeline with multiple NIM services. Yeah. And then, as I said, that cache is on the bottom. The model cache controller controls the NIM caches with persistent volumes in Kubernetes to be able to horizontally autoscale with a bunch of different applications. And for this, I'm going to take you through a demo. We're using Vultr's block storage, container storage interface to achieve this, but it has support for a lot of different storage backends as well. So we're going to take you through a little tutorial to show you how easy it is. This tutorial takes about 10 minutes at the most, and you can get started deploying. And we're going to deploy an 8B model today, but I deployed a 70B in 10 minutes, 15 minutes. It's really simple. So we're going to start with an A100 Vultr instance, single GPU, just virtualized. And we need a boot volume, of course, for some storage, and then access to the NIM containers. So you'll pull the Helm chart for NIM operator, and you set up some secrets to pull it down, and then you'll install it onto your cluster, and it just installs onto any standard Kubernetes distribution, and it does node feature discovery, so you can understand what GPUs are in your system, what it supports, right? And then after that, we'll go ahead and we'll create more secrets to pull models and containers within NIM operator. That's from NGC to authenticate the container pull. This is the NIM cache I was talking about. So as you can see, we're going to deploy the Llama 3.1 8B instruct model on Kubernetes, and so this is the syntax to do that. So we're going to link in our secrets, but the most important part there is that our model engine. I don't know if this has a pointer. Does it? I don't know, that hardly works, but that's okay. We're using the model engine here. We're using VLM with a tensor parallelism of 1. I'm doing that because this is a virtualized A100. This, deployed on virtual and bare metal. There's TensorRT LLM optimized profiles for different GPUs as well. I just chose to use VLM out of the box. It always works. And so, and then down here, we're creating our PVC for our storage backend. So we're creating a 100 gig We're creating 100 gig persistent volume that it can link to all of our different containers. And so after we run that, we'll see that the NIM cache job takes a few minutes to pull down the model from NGC, cache it in storage, and then now we're just ready to deploy as many instances of that as we want. So yeah, it'll download the optimized model profile from NGC using either VLM or TRT LLM. Has a variety of tensor parallelism. So, we had 2 A100s we could deploy with TP2. If we had just one, like we do here, we'll deploy with just one. It also has support for LoRa adapters for your specific business use case, right? And it stores that model in the persistent volume. So now we have a model profile in a persistent volume in Kubernetes. Now we're ready to deploy it, right? So this is it's kind of a two-column Kubernetes manifest that uses NIM operator to deploy this. The most important bits here is that we're using this NIM cache that we cached, which is the 3.1 AP instruct model with VLLM in BF16 when the tensor parallelism of 1. We're only spinning up one replica for right now. We request one GPU. This on the right just sets up our ingress and our ports and endpoints and whatnot. So after we apply all of these, because the model is already cached, it only takes about 10 to 15 seconds for it to actually come up and be ready for inference. And after that, we can curl the model endpoint that is set up. Right here, I'm doing a Kubernetes port forward, but you could set up an ingress with with DNS and whatnot. But after that, we get our response from our model here, and that's pretty much it. It's pretty simple. Are there any questions?
So the model that you showed was a pre-built model, right? But I can bring my own model as well.
Correct. So NIM operator often it will deploy it using the NIM APIs. So yes, if you take your own model and you make your own NIM, that kind of fits into our execution strategy of how literally it's how it's deployed, like deploy.py in the NIM container. Yeah. So you did bring your own model.
So let's just say it is one of the models from a catalog. I take it, but I test it out. It works. POC works. But if I want to scale out, automatically in the backend, it will get the GPUs and storage and so on and so.
Yeah. So I didn't show it here today. But yes, NIM operator has the opportunity to tie into Prometheus metrics on a bunch of things. It's usually the latency of your requests. Or how many requests you're getting, right? So you can set a number of min and max instances depending on how long your requests are taking. Yeah, if I had more time, I would have shown that you could hit it with 10 requests and see that your latency goes up from maybe 200 milliseconds to 800 milliseconds per request, and then that'll eclipse a threshold to then start up another pod next to it and probably do round robin allocation, and then when that average request latency goes down to 200 again, it'll delete it to free up that GPU.
So I can see the stats about the latency and so
Correct. Yeah, that would be that would be probably self-managed because this just views Prometheus TSDB metrics. So you would have to create your own Grafana dashboard to do that. Yeah.
Good.
Yeah, but the data is there. Wow.
Thank you.
I think we have maybe 2 more minutes. Is there any other questions?
Where does that AIQ that was launched last night? AIQ, where does it fit into?
Yeah, so AIQ is still coming out. We're still trying to figure out what the best orchestration strategy is for that. But like I said, AIQ is kind of a pipeline that relies on a bunch of different agents and different experts. And so NIM operator gives you the opportunity to create these NIM pipelines with many different parts of it. Again, I didn't show that today because I just wanted to show really quick how do you deploy one model. But our documentation is on creating pipelines is very good. And there's one example right there that you could do tomorrow.